students, good morning everyone. Okay, in change around us, one last topic we have. Already I explained you about evaporation. Okay, how does evaporation take place and how it is happened and why it is happened and so change of states, melting, so boiling, evaporation, sublimation, and condensation and freezing. These are completed. These are stage of states. So in that evaporation is so what are the factors? What is evaporation said? So evaporation. So how does evaporation occurs? Because of evaporation occurs because of it is a surface phenomena. It is a surface phenomena. So because of that evaporation occurs very having a surface having very high energy. Because of that energy, the water is converted easily to water vapor. They change liquid state to gaseous state. Okay, so a liquid is converts into gas. A liquid state converted into gas. So below 100 degrees Celsius. Then evaporation is occurs. So in summer season, suddenly rain is falls on the roads. Are you observing any water on the roads? So no, because the water is evaporated. Because of the temperature, that surface having the very high temperature, when sudden rain is fallen, that water absorbs the heat energy from the surface of the road, then easily converted into gaseous state. So at any temperature, a liquid state converted into gaseous state is called as evaporation. Okay. So this evaporation is also called as surface phenomena, and also the evaporation is also called as cooling process, because we will feel cool. So already I given an example for you. Whenever you are doing work, you will get sweat. Whenever you get the sweat, you go and sit under the fan. You will feel cool because the sweat is evaporated. Whenever the sweat is evaporated, we will feel cool. So because we will feel cool because of sweat is evaporation takes place. Okay. Next. Okay. The evaporation is depends on some factors. The evaporation depends on some factors. On what factors it depends? So the first one is so the factors affect evaporation. Factors affects evaporation. Okay. So the factors affects evaporation. There are three factors there. One is surface area. Second one is humidity. So third one is wind speed. So there are three factors which will affect surface area. Okay. So whenever surface area increases, okay, I will give one example, best example for you. Take two bowls. So one is the smaller surface area, so another one is the bigger surface area. Okay. So in the two bowls, so fill the water to the neck. Fill the water to the neck. So place two beakers so in a same area, in a particular area. Place into the place outside. Okay. So one, two. Okay. First beaker and second beaker. After some hours, after 12 hours, we can check it. 12 hours after, we can check the water level in the two beakers. Two beakers. So we observe that. So this beaker, so only up to some of the water is evaporated, some less. So less water here, so more water is evaporated. Water is evaporated. So here less water is evaporated, here more water is evaporated. Okay. So because why it is happened? So both are having the same containers. This is the surface area less and surface area is more. So less surface area, they are not exposed more to the atmosphere. They are more surface area exposed to more to the atmosphere. That's why so more amount of water is evaporated here. So here less amount of water is evaporated. So because of surface area more surface area is there, more amount of area will be exposed to the atmosphere, then more water is evaporated. Here surface area is closed, very less surface area, then less water is evaporated. So you have a very good experience about that. So the water in a cup and saucer. Pour the tea in a cup as well as saucer. So two members came to your home. So you can pour one member for a cup and one member in saucer. So in which the tea will be cooled faster in a saucer or a cup. So very easy. It is a very daily life experience to us. So the tea in a cup or a saucer, which one becomes cool faster? So automatically the tea in a saucer becomes cool faster. Okay, because the surface area of saucer is more compared to teacup. So cup having less surface area exposed to the atmospheric air, then automatically so it is evaporation will be less possibility, and here the exposition of evaporation of saucer will be more. That's why the tea cool faster in saucer than the cup. So that is one example, good example for evaporation, and depends on surface area. So surface area is more, evaporation takes place, more evaporation. So both are directly proportional. More surface area, so more amount of water is evaporated from the surface. Okay. So that's why the water from the water bodies will be evaporated faster. So then they form a clouds. The clouds form due to evaporation, and the rain will be fall back into the atmosphere. Next, humidity. So what is the humidity? What is meant by humidity? The amount of water vapor present in the atmosphere. The amount of water vapor present in the atmosphere is called as evaporation. Yes, humidity. So evaporation depends on one of the factors is humidity. What is humidity? The amount of water vapor present in the atmosphere. So the amount of water vapor present in the atmosphere. The amount of water vapor present in the atmosphere is called as evaporation. This is called humidity. It's called humidity. It's called humidity. Okay, what is humidity? The amount of water vapor present in the atmosphere is called as humidity. Okay, so when you observe that rainy season, so the amount of water present in the atmosphere will be more. So whenever you dry the clothes, whenever wash the clothes, and can keep aside on the wall or on a thread. So in rainy season the clothes will dry faster. No. So in winters, in sunny days or summer season, the clothes dry faster because the water vapor in the present atmosphere will be less in a cloudy day. So sunny day, because in cloudy day it becomes rainy season, water vapor present more, the clothes does not become dry. Already more amount of water vapor is there, so that water vapor does not exist in the atmosphere. That's why, so the more amount of water present in the rainy season, so more humidity, and automatically evaporation becomes less. So that's why the clothes will dry faster in sunny day than the cloudy day. So rainy season the clothes does not dry faster because already amount of vapor will be present in the atmosphere. There is no absorption of water vapor from the clothes is not possible. That's why the clothes will dry faster in a summer season than the rainy season. So that about humidity. So humidity will be affect the So this is pressure evaporation. Evaporation will be less in humidity day. Okay, next wind speed. So whenever the wind is blowing, automatically the wind will be carry the water vapor with them and go away from it. So the wind speed is more, evaporation also will be more. So when the windy day, so the cloudy day and the sunny day, the cloudy day and sunny day, or wind is blowing faster, the clouds will be dry faster than the than the cloudy day. So the wind speed also affects the evaporation process. Evaporation is more, so wind speed is more. Wind speed is more, evaporation is faster because the wind blowing with the very high speed. Along the wind, the water vapor also carrying with them. That's why they take out from the water vapor from the clouds, then dry faster. Wind speed is more, automatic evaporation is more. Humidity is high, so evaporation will be less. Surface area is more, then evaporation is more. So these are three factors will be affect the evaporation. Okay, so evaporation. So evaporation depends on three factors. No, surface area. Surface area is more, automatically evaporation more. So evaporation is also more, increases. Okay, so and humidity is more, automatically evaporation is less. Okay, and so wind speed is more, automatic evaporation also will be more. So simple. Okay, so what are the factors will affect the atmospheric evaporation? Evaporation depends on which factors. How does surface area affect the evaporation? How does humidity affect the evaporation? How does wind speed affect the evaporation? They are separately questions, and also they will ask the small question. Explain what are the factors will affect the evaporation. Ask the like there are the questions. Okay, so this is about evaporation. Okay, so this is about evaporation and how it is possible to taking place evaporation. So next, conversion of temperatures. Conversion of temperature. So already, what is temperature? What is temperature? Temperature is nothing but okay. So to measure degree of hotness or coldness of a body. To measure degree of hotness or coldness of a body is called as temperature. So temperature symbol capital T. So what are the formulas to measure, to convert from Kelvin scale to Celsius scale? So how many scales you have? Three scales. What are three scales? So Celsius scale, so Fahrenheit scale, Fahrenheit scale, and Kelvin scale. So there are three types of scales are there. Three scales are used to measure temperature. So Celsius scale, so 0 degrees to 100 degrees varying points will be there, and Fahrenheit scale is 32 degrees to 212 degrees Celsius, and Kelvin scale is 273 degrees to 373 degrees. They are the measuring points in scales. They are the questions. How can we convert? What is the normal human body temperature? The normal human body temperature in Fahrenheit scale is so normal human body temperature. Normal human body temperature. body temperature. Normal temperature is, so how much? 96.98.4 degree Fahrenheit. In Celsius, 37 degrees Celsius. Or so how much in 310 degrees Kelvin. So like that you can measure different scales. 98.4 degrees Fahrenheit, 37 degrees Celsius, and 310 degrees Kelvin. Okay. How can we convert from temperature from one scale to another scale? How can we convert from Celsius scale to Fahrenheit scale? How can we convert from Celsius to Fahrenheit and Fahrenheit to Celsius, Kelvin to Celsius, Celsius to Kelvin? So I have the formulas. I will give the formulas to conversion from Celsius scale to Fahrenheit scale and Fahrenheit scale to Celsius scale, Kelvin to Celsius. Okay. Conversions. Conversions. Okay, how can we convert? Okay, so formula for conversion Celsius to Fahrenheit. Celsius to Fahrenheit. Okay, for that C is equal to 5 by 9 into F plus 32. 5 by 9 F plus 32. So F is equal to 9C by 5 is F is equal to 9C by 5 minus 32. So F is equal to 9C by 5 minus 32. To convert from Celsius to Fahrenheit, okay, and if they give Fahrenheit value, you can find Celsius. If they give Celsius value, you can find Fahrenheit. Okay, from Kelvin scale to Celsius. Kelvin to Celsius. Okay. K is equal to C plus 273. K is equal to C plus 273. C is equal to K minus 273. K minus 273. Okay, like that we can convert that formula for conversion from Celsius scale to Fahrenheit and Kelvin scale to Celsius, Celsius to Kelvin. For example, what is our human body temperature? Normal human body temperature how in Fahrenheit? So F is equal to 98.4 degrees. So Fahrenheit. They given F as substitute here. So C is equal to how much? 5 by 9. 5 by 9. F plus 32. F is how much? 98.4 plus 32. 98.4 plus 32. How much it is? C is equal to 5 by 9. So 98.4 means how much? So 3 plus 2, 6. 2 minus 32. So F minus 32. F minus plus 32. So how much you will get here? It's 66.6. So 66.4 degrees. So 9 7 63. So 36. So 9 4 36. 98.4 here. So 98.4. We get 6. Okay. So what we get here? So 7 point. So 46. 63 means 4. So 9 5 is 45. 9 5 is 45. 7.5. So C is equal to 5 5 is 25. 5 5 is 25. 5 is 35. 37.5. So approximately we get value 37.5 degrees Celsius. So like that we convert from Kelvin scale to Fahrenheit scale to Celsius scale. For example, C is equal to 37 degrees given. So convert and find F is equal to how much? Find F. F is equal to 9C. 9 into 37 by 5 plus 30. So that is 5 1 5 7 35. 5 7 35. More 2. 5 4 20. So 7.4. F is equal to 9 into 7.4 plus 32. How much here? That is 9 4 36. 60, 36 and 60, 66.6. So 66.6 plus 32. How much F is equal to 66 plus 32? How much? 98.6. So 98.6 degrees Fahrenheit. So to convert F is equal to C is 37 given. We find 98.6 degrees Fahrenheit. We convert from Celsius to Fahrenheit or Fahrenheit to Celsius by these two formulas. Okay. So there are two formulas. Convert from Celsius to Fahrenheit and Fahrenheit to Celsius. So next we conversion from Kelvin scale to Celsius scale. Okay, this is about. Convert. So 37 degrees Celsius to Kelvin. They given question like that. Convert. So 37 degrees Celsius to Kelvin. Okay. So what is formula for conversion Celsius to Kelvin? So K is equal to C plus 273. So first write the formula. Okay. How much they are given? C is equal to how much? C is equal to 37 degrees Celsius. So K is equal to C how much? 37. 37 plus 273. How much? K is equal to, so 37 means 270. So 270 plus 33, 300. 300 plus 10, 310. So 310 degrees. So that is for 310 degrees Kelvin. So we can convert easily. Okay? K is for 310 degrees Kelvin. For example, so Kelvin, K is equal to so 273 means for example 340 is there. 340 kelvins are given. So convert them into find C. Convert into Celsius. Convert into Celsius scale. Ask the question. They will ask the question. K is equal to 340 degrees. Convert into Celsius degrees. What is formula for C is equal to K minus 273. K minus 273. C is equal to K how much? 340. 340 minus 273. 273. How much here? 243 means how much here? So 340 minus 273. How much here? So here, so 9, 10. How much here? 7. So 9, 10, 13, 67. So that is 67 degrees. Okay. So C is equal to 67 degrees. Okay. 67 degrees Celsius. C for A is equal to 340. We'll get C is equal to 67 degrees Celsius. If convert K is equal to C is equal to 37 degrees Celsius, we'll get K is equal to 10 degrees Kelvin. So like that, we can convert Celsius scale to Kelvin scale to Celsius scale also. This is very one more question. This is one more question. Convert the following degrees into Kelvin scale to Celsius or Celsius scale to Kelvin scale. Okay. These two formulas keep in your mind. For doing the sums. Okay, one more I will give sums. Convert the following into. So do the following. So convert Celsius to degree Kelvins. Okay, so 27 degrees Celsius. Okay, so 32 degrees Celsius, 18 Celsius. 18 degrees Celsius. So convert this to Kelvin scale. Degrees Kelvins. Okay. So convert degree Kelvin to Celsius. Okay. So 300 degrees Kelvins convert into so 273 2 degree kelvins. So 3 10 degrees to Kelvin, degrees Celsius. Convert these T. So there are the conversions you can do at home. So do the following. So convert 27 degrees Celsius to Kelvin, 32 degrees to Kelvin, 18 degrees to Kelvins. Convert K to C. 300 degrees Kelvin to Celsius. How many Kelvin? How many degrees Celsius? 273 degrees Celsius. 312 to how many degrees Celsius? So the 6 you can do. 4, 5, 6. These 6 questions do at home, everyone. So do the answers following and can write in CW. So these are the question formula. Formula for converting Celsius to Kelvin. So formula for converting Kelvin to Celsius. So these formulas you can note down and do the answers for the following sums. Okay. Students, thank you. So this is the chapter completed. By this we complete the chapter. Okay. So total topics about properties of liquids, gases and solids, and how the CNG used, and what are the properties of the solids, liquids and gases, and also diffusion properties, diffusion and rigidity, diffusion, compressibility, and the space between the particles, how the molecules arrangement will be there, how the attraction takes between the particles. Okay. And also effect of temperature, effect of pressure, and change of states and evaporation. These are the topics are there. I complete these are all the topics, and you go to the total lesson textbook and do the answers for the given questions. Okay, thank you.